All right, so today's warm-up was a review of simplifying radicals. We do that because when you solve an equation using the quadratic formula, you can end up with an exact solution, or you can end up with an approximated solution to the nearest tenth or hundredth. That's what we were doing with the calculators. If we didn't have a perfect square, and we said, all right, it's about 2.58, whatever, then we were approximating a solution. If we're asked for the exact solution, then we need to leave it in a simplified radical expression. So that's what we're going to review here, and then we'll apply it to one quadratic formula problem. All right, square root of 64 is really easy, 8, done. Square root of 75, not quite as easy. So what I'm going to do is I'm going to break it down to a prime factorization. So 75 is 3 times 25. I can break 25 down further. I have 5 and 5. All right. So now if I put these back in, I can say here 5 and 5 is my perfect square. So that's 5 times 5 is 25. So I'm going to rewrite this using that 25, but I can't ignore my 3. So I'll have square root of 25 times 3. These are equivalent, right? Okay. Now that I have a perfect square here, I can pull out the square root of that. Square root of that is 5. So I can pull that out of the radical. So that equals 5 times radical 3. Done. And that's as simplified as I can get. All right, let's do it again. Radical 80. Prime factorization. If you can already see the perfect square, great. I can't. So let's see. 4 and 20. Break down 4, 20, 2 and 2. I got to break down 20, 4 and 5. I can't break down 5, but I can break down 4 more. 2 and 2. All right, so that means I have 2 and 2 and 2 and 2. So I've got these two partnered up and these two partnered up. Now, I showed you one way to think about it. Here's another way. These are already square roots, kind of, right? If I just take one of these 2's here and one of these 2's here, I can skip this step and I can pull it straight out of the equation. So I would say that's 2 times 2, because that's one of these 2's and one of these 2's pulled out, times radical 5, because I can't forget that 5. Now, if that's too big of a jump for you, no problem. You can do the same thing that you've done before. And so I'd have to still multiply this out. It would be 4 radical 5. So let me show you the other way. I would say that's equal to 16 times 5. Where did this 16 come from? Well, that's 2 times 2 times 2 times 2 is 16. I lied. That's 4 times, 2 times 2 times 2 times 2. Yeah, that's 16 times 5. Well, now what's the square root of 16? Is 4, so I'm going to pull that out. That equals 4 radical 5. So whatever method works for you, okay? All right, let's keep going. Radical 50. Hey, I can see a square root here easily. That's the same as radical 25 times 2. And, well, if I pull out the square root of 25, I'm going to pull out 5. I have 5 radical 2. Done. Same thing with radical 18. I can see that that's equal to 9 times 2. And 9 is a perfect square, so I can pull out that 3. Equals 3 radical 2. Nice. Oh, look at that. Miss Decker's throwing us a curveball. We have a fraction here. Okay, but I'm going to deal with just this radical because this is not under the radical sign. So radical 12, well, that's the same as radical 4 times 3, all over 2. And now I can pull out the square root of 4. That's going to give me 2 radical 3 over 2. Can I simplify more? Yes, I can. 2 divided by 2 is 1. So I can cancel those out, and I'll be left with just radical 3. Right. Notice that I can't simplify, I can't divide from within the radical sign. Right? I've got to wait until I get it pulled out, and then I can divide. All right. Radical 32 over 2. Well, that's radical 16 times 2 over 2. Again, I can't just pull these 2's out, right? I've got to get it out of the radical symbol first. So let's see, square root of 16 is 4, so I'll have 4 times radical 2 over 2. And now I can simplify. 4 divided by 2 is going to leave me with 2, so I'll end up with an answer of 2 radical 2. Done. Oh, look at this, a fraction and a variable. Okay. Radical 150 over 2a. Let's see, I got to do the prime factorization. 150. Well, that's the same as 5 times 30. That's the same as 5 times 6. And I could leave it here, but just to be safe, that's 2 times 3. All right, I have my 5's here. Those are partnered up. So I could just say that's 5 radical 6, right? That's one of these partnered up, and 2 times 3 is 6. Or I could do it the longer and safer way. I could say, well, 5 times 5 is 25. Let's leave that under the radical sign. 25 times 6, because that's that 2 times 3, over 2a. 25 is a perfect square, so I can pull that out. That's 5 radical 6 over 2a. And can I simplify more than that? No, I can't, so I'm done. All right, last one. 6 plus radical 28 over 2a. Simplify the radical first. That's 6 plus 4 times 7 over 2a, right? And now 4 is a perfect square, so I can pull that 2 out. I'll get 6 plus 2 radical 7 over 2a. And now I'm going to, I can divide each of these by 2, so I can cancel it by 2. 6 divided by 2 is going to be 3. 2 divided by 2 is going to be 1. So I can simplify to 3 plus radical 7 over a. Now, technically, I could have gone another way, so let's take a look at that. Rather than leaving it like this, oops, what happened to that last one? Okay, apparently I decided I didn't want to show you that one, but I do want to show you that one. So what I can do instead from this step, let me do that in green. So I could say equals 6 plus 2 radical 7 over 2a. And then I could have said, well, that's the same thing. Oh, no, I can't. Ignore me. I'm not going to cut this out, so just deal with it. Haha. Okay. All right, so let's do number 7 from the homework together. There's the problem. 5x squared plus 30x plus 32 equals 0. And because we're told to, we're going to use the quadratic formula. But for this assignment, even though it says to round your answer to the nearest hundredth, we're going to give exact answers, which means if we have a non-perfect square radical, we're going to just leave it as a simplified radical. All right, so there's my a, b, and c, 5, 30, and 32. And then I'm going to rewrite the quadratic formula. Negative b plus or minus radical b squared minus 4ac over 2a. And now I'm going to substitute in what I know. Negative 30 plus or minus radical 30 squared minus 4 times 5 times 32 over 2 times 5. And now I'm going to start simplifying. I can't do anything with negative 30, but I can figure out 30 squared. So I've got negative 30 plus or minus 900 minus 640. So I figured that all out, and then I figured that out over 10. Okay, so all I did was simplify 30 squared, 4 times 5 times 32, and 2 times 5. All right, I'm going to move up here, and I can simplify a little bit more. 900 minus 640, what's that? Well, that's going to give me negative 30 plus or minus 260 over 10. Okay, and now some of you right now feel like you want to just divide by 10 and get rid of the zeros, but remember you can't. This is in the radical, so we cannot just do that. But we can simplify that radical. I need to do prime factorization. 260 breaks into 2 times 130, which breaks down into 10 times 13, which breaks down into 2 times 5. Where are my partnerships? There's my 2's. So I can pull my 2 out. But I'd have to deal with still 5 and 13, so that's going to stay in there. So I'll have 2 times, because that's the square root of 2 times 2, right? Radical, what's 5 times 13? 65. Okay, so radical 260 is equal to 2 times radical 65. All right, so let's write that. Negative 30 plus or minus 2 times radical 65 over 10. Okay, and can I simplify that some more? Yeah, I can divide everything here by 2. That's going to give me negative 15 plus or minus radical 65 over 5. Although some might argue that a better way to have dealt with this, I'm going to do that in green right down here. So for me, this is an acceptable answer. And if that's on your multiple choice test, you're done. But what if this isn't on your multiple choice test? Well, then you need to think about, well, did they simplify it more? Well, I could simplify it more. negative 15 over 5 plus or minus radical 65 over 5, right? Because this is just each term divided by 5, so I can rewrite it like that. And then I can say, all right, negative 15 divided by 5 is negative 3 plus or minus radical 65 over 5, because I can't simplify that anymore. Now I'm really as simplified as I can get, and I'm done. All right, see you in class.